So far, we learned about matter and we break it to molecules and discovered their properties. And now, it's time to break the molecules to understand how they form. So, from matter to molecules, and if we continue breaking molecules, we'll end up with atoms, which is the smallest individual unit of matter, which can share in a chemical reaction. So, the part of matter that share and enter chemical reaction is atoms. And in this lesson, we'll study the chemical symbol of element, the atomic construction, and the electronic distribution. So, chemists use symbols to express element easily, and each symbol represents one individual atom. And here are some elements like hydrogen, potassium, aluminum, iodine, phosphorus, fluorine, silicon, lead, neon, chromium, oxygen, silver, bromine, mercury, zinc, beryllium, fluorine, sodium, gold, sulfur, copper, calcium, boron, lithium, nitrogen, carbon, helium, magnesium, argon, and iron. And those symbols are derived from the Latin name, and they could be one letter written in capital, like sulfur, carbon, and hydrogen. And maybe two letters, the first letter in capital and the second letter is small, and that's to differentiate between the elements which have the same first letter, like calcium, silicon, and helium. And notice that the element symbol are derived from the Latin name, so their symbol may differ from their name in English. So sodium, natrium, Na, potassium, kalium, K, iron, ferrum, Fe, copper, caprum, Cu, silver, argentinum, Ag. Second, the atomic construction. First, the atom has nucleus, which is the central core of the atom, and the mass of atom are concentrated in nucleus. And the nucleus consists of two particles, proton, which are positively charged particles, and neutrons, which are neutral particles. So protons has a positive charge, the neutron doesn't have charge, neutral particles. And that's why the atom is a positively charged. Second, the electrons are tiny particles that revolve at a high speed around the nucleus in an area we call energy level. And they are negatively charged particles. They have negligible mass. We neglect their mass because it's so tiny. And the number of negative electrons equal the number of positive protons. So the atom is neutral because we have protons in the nucleus, positive. Around it revolve the electron, which is negative, and they are equal in number. So the atom is neutral. So the energy levels, they are imaginary region around the nucleus in which the electrons move according to their energy. And the maximum number of energy level in the heaviest atom is 7. We have only 7 energy levels. And the energy levels are arranged according to the nearer to the nucleus from inside to outside, K, L, M, N, O, P, Q. And each level has a certain amount of energy that increases by increasing the distance. So the least or the smallest energy is K, and the largest energy is Q. And then K smaller than L, M is larger than L. So the first energy level K has the least energy. The seventh energy level Q has the highest energy, and the the energy of level L is greater than level K, and the energy of level L is smaller than level M. And the energy of electron equal the energy of level which revolve in. So for an electron to move from one level to another, it has to gain an amount of energy we call quantum. This quantum equal the difference of energy between the two levels. So for example, for an electron to move from K to N, it has to gain an energy amount exactly equal the difference between energy between K and L. So the electron is not transferred from one level to a higher one unless it gains some energy called quantum, which equals the difference between the energies of two levels and the atom. In this case, the atom that gain energy called an excited atom. So the quantum is the amount of lost or gained energy by an electron when it transfers from one energy level to another. The excited atom is the atom that gains quantum of energy. So how can we express an atom? We use two terms. The mass number, which is the sum of protons and neutrons, and we write it above the symbol. Second, we have the atomic number, which is the number of protons, and we write it below the symbol. So the atomic number equals the number of protons and also equal the number of electrons, and the mass number equal the number of protons plus the number of neutrons. The number of neutrons may be equal the number of protons, as in carbon, because carbon mass number equal 12. Atomic number of carbon equal 6. So the mass number equal atomic number plus the number of neutrons. So 12 will equal 6 plus 6 neutrons. Or the number of neutrons may be more than the number of protons, like sodium. So mass number of sodium equal 23. Atomic number of sodium equal 12, with the number of neutrons in sodium equal mass number minus atomic number, with 23 minus 11 equal 12 neutrons. And notice that the nucleus of hydrogen doesn't contain any neutrons. So the atomic number of hydrogen equal the mass number of hydrogen. So what will happen if the number of protons change? First, the value of the positive charge of nucleus change. The value of the atomic number and mass number will change. So the element will be completely different element. So the element change into another element. So what is meant by the atomic number of calcium equal 12? So the atomic number equal the number of protons. So that means that the atom of calcium has 20 protons. So that means that the number of protons in the nucleus of calcium equal 20. What is meant by the mass number of calcium is 40. So we know that the mass number is the sum of the protons and neutrons. So this means that the sum of number of protons and neutrons in the nucleus of calcium equal 40. So why the mass number is always larger than the atomic number? Because the mass number is the sum of the atomic number plus the number of neutrons. but the atomic number only equals the number of protons. So because the mass number equals the sum of number of protons and neutrons in the nucleus, but the atomic number only equals the number of protons. So what happens when the electron gains quantum of energy? So the atom will become excited and the electron will transfer from its energy level to another energy level. It will transfer to a higher level and the atom becomes an excited atom. So what happens when the electron in the excited atom loses a quantum of energy? So the electron will return back to its original energy level. So if the nucleus of oxygen contains 8 protons and 8 neutrons, find the atomic number and the mass number. So mass number equal number of protons 8 plus the number of neutrons 8 be 16. So we'll the O, write the mass number above the symbol and the atomic number below the symbol. Second, if the nucleus of a sodium atom contains 11 protons and its mass number is 23, so find the atomic number. Okay, the mass number equal atomic number plus the number of protons. If the nucleus of a sodium atom contains 11 protons and its mass number is 23, find the atomic number and the number of neutrons. The atomic number is the number of protons. So it has 11 protons. Okay. Second, the number of neutrons. The mass number equal the number of protons plus the number of neutrons. So the mass number is 23 equal number plus the number of protons, which 11. So the X number of neutrons will equal 23 minus 11 equal 12 neutrons. The positive figure represents the nucleus of fluorine atom. The number of electron, okay, number of electron equal the number of proton. So it has 9 proton, will have 9 electrons. The atomic number is the number of protons, 9 protons. The symbol of the atom. Okay, to write the symbol of the fluorine, if above the symbol we write the mass number, so the mass number equals the number of protons plus number of neutrons. 9 plus 10 equals 19, and below we write the atomic number, which is the number of proton, 9. Thirdly, we have electronic distribution. Each energy level can take a definite number of electrons. The least energy level are filled first, then followed by the higher energy levels. The number of electrons which saturates the first 4 energy level can be calculated from the relation 2n squared, where n is the number of energy level. So for the first level, K number 1, so 2 plus 1 square equal 2 electrons. The second electron, energy level L, number of energy level 2, so 2 multiply 2 square, 8 electrons. M will be 18 electrons, N will be 32 electrons. And know that the relation 2n square don't apply to the energy level higher than 4, because any atom that becomes unstable if the level contains more than 32 electrons. And the outermost energy level of any atom can't take more than 8 electrons, except for energy level K, take only 2 electrons. So for the K, for potassium, K, it has 19 electrons. So how can we distribute? So we have K, we say K only take 2, L 8, M, okay, so 9. No, we said that the energy at the outermost energy level can take more than 8 electrons. So for the K will be 2, L 8, M 8, N 1 electron. Okay, 2, 8, 8, 1. And the chemical activity of the atom are determined by the electron in the outermost energy level. So for the inactive element, the outermost energy level are completely filled with 8 electrons, except for helium, 2 electrons. They are stable and don't take part in chemical reactions. But the active element, the outermost energy level contain less than 8 electrons, and they share and take part in a chemical reaction to form a stable molecule. So for the helium will be K1 will be active because it has less than 2 electrons. For helium, 2 electrons, so it's in act. Lithium, so the L should have 8 electrons, but it has less than 8 electrons for lithium, so lithium is an active element. Nitrogen, the outermost energy level contains less than 8 electrons, so it's active. Oxygen, again, the outermost energy level contains less than 8 electrons, so it's active. Neon, the outermost energy level contains 8 electrons, so it's inactive. Sodium, the outermost contains less than 8 electrons, so it's active. Magnesium, the outermost energy level has less than 8 electrons, so it's active. Aluminum, outermost energy level less than 8 electrons, so it's active. Chlorine, outermost less than 8 electrons, so it's active. argon outermost energy level contains 8 electrons, so it's in